This is simple cubic structure, right? Simple cubic structure. SC, we call it as SC. So in this red diagram, there you see a kind of this box is drawn in a lighter lines, you see. Okay, so this is 3D. You see, this is one face. If you assume as front face, this is side face, and that is back face. This is top face, this is bottom face, right? So these will form bottom face, these will form top space, these four will form front face, these four will form side space, right? So this is a 3D structure. Can you imagine this structure is actually being here? This line here, this line here, this line here, this line here, this line there, right? This structure is known as simple cubic structure. All right. So this is how you have seen, right? This is the diagram which I have shown in the left side. So that's a cube, and this is how this cube is formed. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. By these 8 atoms, you see 1, 2, 3, 4, 5, 6, 7, 8. This is formed. All right. Pay close attention to these quarter pieces. You see this quarter piece, and all, right? So now, by these lines, right? By these lines, the volume enclosed is only this much. So you see, these are 4 atoms, which are actually 1, 2, 3, 4, 5, 6, 7, 8. Now I am going to join them with the same link like this. Okay, so from here I will draw like this, I will draw like this, and like this. So now this part is complete. I have joined 4 atoms with 4 lines. Now this, and this, right? So this part is now complete, and now I will complete this and this. This one I will draw in dotted line, because since that is in the other part, you cannot see actually, right? All right. So I have drawn this particular diagram as this diagram, right? Now, the volume enclosed by the lines which I have drawn, you see the lines which I have drawn, if I actually cut them, that will look like this. So here and here, due to this line and this line, 1/4 of a complete molecule will be removed, right? So by this line and this line, you see this and this particle is removed. Similarly here, right here, from this line and this line, all right, this part is removed, right? So that is this part. From this line, and this line, you now see this part is removed. Similarly here, 1, 2, 3 these lines, this part is removed, right? So similar case will be applied for these 4 structures also, these 4 atoms also, right? So what I want to show you is 4 atoms and 4 atoms, totally 8 atoms are there in simple cubic structure, first thing, okay, and those are in contact with each other, right? And if you see, when you draw a cube considering all 8 atoms, that cube will enclose only these parts. So this atom now will be something like this, okay? If I assume this atom as This will be the atom, right? Similarly, this atom will be something like this. This atom will be something like this, and here this will be something like this, right? Similar case in the back side also. So front side 4, back side 4. So now see, if I draw this one completely, I can obtain this diagram, right? So by drawing these lines, I can say in unit volume, right? So that's why I told you about the unit volume. So here unit volume means this length is 1, this width is 1, depth is 1, all right? In unit volume, how many atoms I can have and how much is the empty space I can predict, right? So this region where we don't have any atoms is the empty space. This region where we have the atoms are the parts where the atom will be located, right? So why I do this is to calculate in unit volume how much percentage is occupied with the atom and how much percentage is empty. You take like 8 small balls which can be cut, or even 8 this limes are fine. You take 8 lemons and arrange them in a way so that you can see. So what you have to do is you arrange those 4 limes, right? Insert a like metal rod through the center, only through the center, through this center to that center, that center to that center, like that, okay? And then along that metal rod you cut them, right? You cut them and see in the cube, right, in the unit cube, how many lemons you have. Or else if you don't have 8 lemons, you can do one more thing. You take 1 lemon, okay, and cut it into 8 pieces. 8 pieces means each piece should have a shape like this, okay, and arrange them in a way like this, okay, arrange them in a way like this, all right, and then you draw a cube beside that, right, and then calculate how much is the space occupied by the lemon and how much is the empty space. So if this idea is to those who still face difficulty in understanding this one, right? Now I need to find in unit cube how much percentage is actually occupied with the atom and how much percentage is empty void. So we only concentrate on this region. So unit cubic structure 1 by 1 by 1. So we can calculate the volume of that unit cube, draw 1/8 of one sample. So you can calculate the volume of that. So if you reduce one from the other, you will get the final answer, right? So when you see this one, you see here 1, 2, 3, 4, 5, 6, 7, 8 pieces of 1 into 8. So the pieces which are already aligned like this, right, aligned like this, is now taken into you see 1, 2, 3, 4, 5, 6, 7, 8 pieces of 1 into 8 length. So these 1 into 8, now you see 1 by 8, 2 1 by 8 forming now 4, right? These 4 1 by 4 forming 2 1 by 5. You see this 1 by 4 and this 1 by 4 forming a half, this 1 by 4 and this 1 by 4 forming a half, and this half and this half is now forming a full object, you see. So actually in this cube, right, in this cube, the volume occupied by all these 8 atoms is actually the volume of one atom, right? 4/3 pi r cube, right? Here you know this is length into width into height, right? So if you have the volume of this, right, volume of cube, if I say length into breadth into height, and volume of cylinder cylinder that is equal to 4/3 pi r cube. All right, 4/3 pi r cube. Now I need to find how much is this void space is. So there I will reduce the subtract the volume of cylinder from the volume of cube. That will give you the volume of empty space. All right. So LBH minus 4/3 pi r cube will give you the empty space. All right. So this R will be given. Right. This R will be given. You need 4/3 pi r cube, no? So 4/3 is a number, pi is a number, r cube. R I will give. So you can find the volume now. So in this one cube, you have 8 pieces of, right? 8 pieces of atoms of 1/8 of each atom. So now we have 4 plus 4, 8. You know, structure atoms 4/3 pi r cube. All right. If I consider one side of the cube as A, unit volume A, right? Unit volume A. So which means the volume is A into A into A. Is that thing okay? Volume of cube is equal to A height into A length into A, that is width, that is A cube. Is that okay? Similarly, volume of sphere, right? Sphere is this one. So you have seen that is one sphere at all. So 1/8 into 8 pieces. So 1/8 volume into 8 pieces of structure atom. So that is one atom. So volume of sphere is 4/3 pi r cube. Now R, you know, this is A, right? This is A for the cuboid. In 1A there is 2 R, right? You see 2 cylinders, 2 sphere parts are here. So I can say this as R and this as R, right? So from there you can say A is equal to 2 R, right? Because here one atom, here one atom, 2 atoms making 1A, that is A is equal to 2R. Then R is equal to A by 2, that is 0.5 A. Okay. Now I will put this 0.5 A into my equation. That is 4/3 pi r cube. R is 0.5 A cube. Sir. All right. So I'll substitute this R with 0.5 A whole cube, right? So that will give you 4/3 into pi, you know, 22/7 into A cube into 0.5. So 0.5 into 0.5 into 0.5, how much? 0.25, 0.125. 0.125 A cube. All right. Now, you see here, one atom into found 1/4 pi A cube. I don't need the exact value, but I just need the ratio, right? So if I divide this with this, that's what happened here. This value is here, and this value is here, right? So 4/3 pi A cube divided by A cube, that will give you 0.52. So your A cube and A cube will be cancelled, right? At the bottom you have 1. At the top you may have 4/3 into pi into 0.125. 125. So if you substitute, you will have 0.52, right? So here in simple cubic structure, right? In simple cubic structure, the ratio of atoms to the ratio of void space is 0.52. So here in the simple cubic structure, only 0.52% of the volume is filled with atoms, while 0.48 rest of the percentage is empty. All right. Now I am going to introduce you certain terms, right, which is accompanied with this calculation. Now we just have said radius and volume and cube and sphere and all, right? So now I am going to introduce you certain terms which are accompanied with. Here you see APF, atomic packing factor, right? APF we call it shortly, atomic packing factor. This atomic packing factor is given as volume of atoms in unit cell over volume of unit cell. You need to understand the difference between these two. Volume of atoms in unit cell. So that is this atom, this atom, this atom, this atom, this one, this one, this one, and this one. Right. So volume of atoms in unit cell divided by volume of unit cell. Volume of unit cell is this into this into this. This is the volume of unit cell. Right. So this A cube is the volume of unit cell, and here this 4/3 pi r cube is the volume of atoms in unit cell, right? So what you have calculated so far is known as atomic packing factor, right? So atomic packing factor for simple cubic structure is 0.52, right? So while we are calculating, we never go into these names. Now I am introducing the names, right? If I introduce the names by that time, that will be complicated. So what you have calculated as the volume of atoms in unit cell over volume of unit cell is 0.52, which is known as atomic packing factor for simple cubic structures. Okay, we are talking only about simple cubic structure by now. Close pack directions contains 8 into 1 by 8. So this 8 into 1 by 8, we have 1, 2, 3, 4, 5, 6, 7, 8 atoms, right? 8 atoms. They are not total full atom, just 8 atoms, and 1 by 8 of each atom is actually incorporated here. So this particular region is 1/8 the volume of a one sphere, right? Rare due to low packing density. Only PO has this structure. So rare due to low packing factor. So this structure, right, simple cubic structure is existing only on polonium, right? Polonium. Close pack directions are cube edges. Coordination number 6. So this coordination number means an atom, any one of this atom, right? Any one of this atom. It need not to be this atom or that atom or this atom. Any one of this atom forms contact with how many other atoms, right? So if I take this atom, right, this is in contact with this atom, right? These are in touch. This is in contact with this atom. These are in touch. This is in contact with this atom. Okay. And if I place another layer here, oh no. If I place another layer of atoms here, right, this will be in contact with the atom on the top also, right? So this atom also it will be in contact with. And this will be in contact with an atom which is on this side, right? I can draw certain atoms to this side also, right? So this is going to be like this. Throughout this one, I can draw atoms like this. Similar way here also I can draw atoms like this. Downward also atoms I can draw. So this is a continuous structure. Okay. Just for the sake of easiness, we take 4 and 4 atoms to explain you. Right. So if this red atom, right, this red atom is your this atom. If I assume this as this red atom, so this way one, that is this one, right? This white one, that is this one. Top side one, that is this one. This side one, that is this one. This side one, right? In front of the atoms, no. So that is this atom. And in the bottom side one, that is this atom, right? So totally an atom in simple cubic structure can be in contact with 6 atoms, right? I repeat, in simple cubic structure, any arbitrary atom can be in contact with 6 atoms, right? I am talking about contact, so this and this should touch, they should share the surface. This and this are not in contact, right? This and this are not in contact because in between there is a void. You see here and here, that is not contact because there is a void, right? But this and this are in contact. You see here there's a contact, right? So coordination number is 6 for simple cubic structure, and the meaning of coordination structure is nearest neighbors or the atoms which are in contact, right? Nearest neighbors or the atoms which are in contact. And usually these distances will be equal for all 6. So this, if I consider this as distance A, this one, here, here, all distance will be A probably, right? So the coordination number is the nearest neighbors which are in contact with each other. So for simple structure, simple cubic structure, the coordination number is 6. So what actually you are seeing at the moment is about simple cubic structure, okay? SC structure. So 1 2 1 2 1 2 1 2. There's no body and all, right? This is simple cubic structure, right? You see here, there is nothing in the body, so that is simple cubic structure. In this one, right, there is a pink atom and there are 1 2 3 4 5 6 yellow atoms. All right, this is for the coordination of the coordination number of the simple cubic structure, right? There you see this pink atom is in contact with only these 6 atoms, right? So that's why the coordination for simple cubic is 6, right? So if I can draw, so this pink is in contact with 1 2 3 4 5 and 6, right? So this is for the coordination number of the simple cubic structure 6, right?